All right, gentlemen. So the next topic we're going to discuss is we're going to move on with the organization of elements and the organization of the periodic table, and what other information can the periodic table tell us on top of what we've already discussed. So we've already talked about atomic number, atomic mass, mass number, and our subatomic particles, protons, neutrons, and electrons. So let's get started and look a little bit more on a broader scale how we organize these atoms. So remember, guys, the most important thing that we need to know is that elements are pure substances. They're the simplest form of a pure substance, and they're made up of atoms. And remember, atoms are the smallest part of an element that can keep its properties. So by looking at the periodic table, we not only know that elements are organized by their atomic number, but when we look at it in specific ways, we can see that the properties of elements are going to be either the same or a little bit different. And that's what we're going to look at now. We're going to look at, on a broader scale, how are our elements organized. So in the last video, you spent a lot of time looking at each individual element square and what information that can tell you. So atomic number, atomic mass, it can tell you how many protons, neutrons, and you have the numbers to find your number of electrons. But the one thing we didn't cover was we didn't talk about the name and the letter symbols that's given for each element. So each element has not only its English name, but it has a specific set of letters. Okay, normally a capital and a lowercase or just a capital letter that represents it. Okay, that's what we use for our formulas and our reactions. These symbols are normally related to the English language, okay, or their English names, but not always. Some of their names come from older names, okay, normally Latin, so that their symbols don't quite match up with their English names. So we have a couple of examples here. Gold, okay, gold symbol is actually AU, right? It's AU because of its old name. Iron, maybe some of you know this, some of you may not, okay, is Fe. So both of these have their symbols that come from older names. So if you know perhaps that sodium is Na, or silver is Ag, right? Some of these you just are going to have to learn and kind of muddle your way through till you get them down, because they don't quite match up the way you would think they do. So the first key we're going to look at in the organization of the periodic table is we're going to look at groups. So that's these up and down vertical columns of elements. So these groups, or these vertical columns, are also called families. And we're really going to be looking at the columns 1 through 18, or they're 1A through 8A. So right now, the important columns for us are going to be 1, 2, and 13 through 18. Okay, we're not going to focus on that center section right now because it's a little bit different and doesn't follow necessarily all of the standard rules compared to everything else. So in these groups, or in these families, they have similar chemical properties. So their properties are either going to be really, really similar, or they're going to be almost exactly the same as you look up and down these columns. So up and down, you have similar properties. Now we're going to look at left to right. When reading the periodic table left to right, we're looking at the horizontal rows. Okay, these are called your periods. So there is a total of 7 periods. You can see it labeled right here on the left side in the picture. Okay. And periods are different from your groups because the properties actually change. Okay, the properties do not change stay the same as you move left to right across the periodic table. So you can see in this picture that the elements are colored a little bit different. And we're actually going to talk about why that is and what that means, and kind of how this change in property plays an effect into our general way of organizing the periodic table. There are three major ways that we organize the periodic table, or three general categories that we can organize the periodic table in. First one of those is metals. So most of the elements on the periodic table are considered metals. Okay, how do we determine that something is a metal? Is really dependent on its properties. So the few properties that we really tend to look at are listed here. So it's a conductor of heat and electricity. So if you think about something like copper used to be used very prominent in wiring houses because it's an excellent conductor of electricity. Okay, most of these metals are solid. Okay, the only metal that is not solid at standard temperature and pressure, okay, so that means our everyday temperature and pressure, is mercury. Mercury is a liquid at standard temperature and pressure. So pretty much all of our metals are going to be solids. Okay, metals also have properties such as being malleable, ductile, and magnetic. If you think about iron, okay, if you've ever seen like iron filings and you put a magnet near them, it's going to attract. That's kind of what's in those like Etch-a-Sketches they have for little kids, is because it's a magnet with a magnetic metal. On the opposite end of the spectrum, we have our nonmetals. So as you can see from this picture, the right side of the periodic table, with the exception of hydrogen, okay, hydrogen all by itself right over here, all of your nonmetals are located on the right side of the periodic table, okay? So these elements, just like their non-metal name, okay, are the opposite of metals in their properties. So they're poor conductors of heat and electricity. That means for the most part, they tend to be used as insulators. So they will insulate and keep things in. Okay. And also, just like the opposite of metals, nonmetals are mostly gases at room temperature. So we're going to talk a lot about that and what that means, but they're mostly, for the most part, found as a gas, so we can't actually see them. The few that are solids are normally brittle and they're not malleable at all. So if you try to like hold them in your hand or smush them, they're just going to turn into a powder. A great example of that is what you see in this picture right here. That yellow chunk is actually sulfur. Okay, it's pure sulfur. So sulfur is a solid at standard temperature and pressure, and it's a yellow solid. But if you try to really do anything with it, it's just going to kind of smush into a powder in your hand. So unlike the solids in metals, there really isn't a lot you can do with non-metal solids. Last but not least are our few elements that don't really classify as metals or non-metals, okay? They're a little bit in the middle. So we call these metalloids or semi-metals. These are elements that have characteristics of both metals and non-metals, okay? And they make kind of a staircase on the periodic table. So they're listed all right here. And if you look at a periodic table and compare where these elements are, you'll see they kind of go from left to right, forming a staircase down the periodic table. The kind of weird thing about metalloids is that because they have such a wide variety of characteristics, they're really not all of that similar to each other. Okay. If you look at something like malleability, okay, or being brittle, the only really way we can describe them is that they're less malleable than a metal, but they're also less brittle than a non-metal. They kind of just fall right into the middle, okay? So each individual metalloid is going to have one or more characteristics that can go on either side of the spectrum. So next video and next class, we're going to look at the periodic family. So we're going to break this down even more, and we're going to label what our periodic families are and kind of what their properties are and a little bit of what they're used for. Okay, let me know in class if you guys have any questions on this, and I will talk to you guys next time.